One of the least fun parts of science is that most of the time when you try something for the first, second, and probably 15th time, it doesn't work and you don't often know why. So it's a slow process of carefully eliminating all the variables until you find the problem. These past weeks have been a lot of that. Over the past couple of months, I've tried several different transformation protocols that use a variety of methods to put new DNA into bacteria. And thus far, every time I tried, stuff would grow on the plate but clearly hadn't taken the mod. This is super weird, and it took a little while to figure out what was going on. After setting up an antibiotic test, it turned out that the sample that was supposed to be just basic normal E. coli was actually completely resistant to the antibiotic I've been using. So there was no incentive for them to pick up the new DNA if it contained antibiotic resistance that they already had. This means a few of the videos I had planned for the next couple of weeks aren't possible until I get a fresh sample, which, while frustrating, isn't the end of the world, and I've already got fresh supplies on the way. But it has meant moving the video schedule around and switching to other projects while I wait. To that end, I've been struggling lately with various basic protocols not working properly, so I've been cleaning, testing, and retesting everything in the lab to remove as much error and increase success of the various experiments. And it's totally working, and things are getting way better. But that's not actually interesting to watch, nor do I feel like filming it, as it's stuff we've already covered. So instead, this week I want to talk about and show off some clips of projects currently in the works, as well as go over projects that are coming up and answer some viewer questions. It's been a while since we did a grab bag video, so I figured everything failing was as good a reason as any to do one. So let's jump right in. First up, one of the many reasons I needed that E. coli is because I built this. It's an electroporator, which means it uses a pulse of high voltage electricity to open holes in an organism's cell wall and force some DNA in. The whole thing happens so quickly and is gentle enough that many of the cells survive this without issue, and are instantly genetically modified, though it can take some time for the new DNA to start working. I love electroporation because it's such a quick procedure and so much more effective than things like heat shock. Best of all, while this looks fancy because I made the housing on the lathe, the core is a simple piezoelectric igniter taken from a $2 click lighter. So as soon as I've got some fresh bacteria samples, we'll go through the build and give it a test drive. And before you ask, I got the idea from a recent iGEM team and paper, I didn't come up with it myself. A viewer sent me a link to the paper on Twitter, and I knew I had to make one, with a couple modifications of my own. Another super quick bio update is that I recently managed to get 2 fresh spider specimen and a whole box of new supplies, so if all goes well, I should hopefully make some more progress on the Silk project soon. And finally, before we get to the viewer questions, one last quick sneak peek. Those of you that follow me on Instagram probably saw me tinkering with these. They're microfluidic cells that use tiny fluid channels to accomplish a variety of things, be it mixing, filtering, sorting, and analysis. These were made on the CNC router and were cut from shrink film, which is normally a kid's toy. The idea is that you put a pattern on the film and then bake it, and it shrinks to about 1/4 to 1/5 of the size. As such, I can carve much larger patterns and then just shrink them to the final size I want. I've got a much more difficult project than a simple mixer in mind that ties in many of the other things we've looked at recently. But because of the difficulty, I've been making these little prototypes to test various features that will be in the final design, as well as to just practice and get used to the technique, as it's sorta weird and finicky. For the final design, which is meant to sort individual yeast cells and pick out the genetically modified ones, it will require custom DIY pumps, upgrades to the fluorescent microscope, these microfluidic cells, and maybe even a bit of computer vision to control the sorting process in real time. I'm excited, but it'll take a little while to get it working. So while I practice and refine the idea, I'm going to go through a lot of other simpler designs, and we'll do an introductory overview video on microfluidics, and, importantly, cheap DIY methods of making the various flow cell designs. Thus far, I've only made a few cells, so my technique really needs work, but I'm learning a lot and look forward to sharing all I learn with you soon. Okay, question time. First, many of you have asked what's happening with the radio projects, so I figure I'll just do one big update here. As I've said many times, but will reiterate here, Canadian winter takes up like 3/4 of the year, and during that time, radio is an absolute no-go. None of us feel like setting up delicate equipment in the snow or sitting outside when it's -40. Celsius or freedom height, you ask? It doesn't matter. So once things thaw, we'll be at it again. The day I made this, it was actually sunny and 10 degrees out, so everything should be melted soon. In fact, one of the projects may even get started in the next week or two if we get some time. So, what am I planning with radio this year? Well, first, Pipsqueak is getting an overhaul and will finally be field tested. Once he's fully functional, we'll be making a radome for him and we'll be mounting him on the roof of my friend's building permanently so he can be controlled remotely. We'll use him to get data off of new satellites, continue to use him for GOES reception, and so much more. The overhaul and installation will be a big project, so expect a couple videos on that, and putting him to good use during the summer if everything goes according to plan. Last year, a viewer was kind enough to send me a pair of these amazing, directional, super wideband antennas, and I've wanted to make use of them since. So in the next little while, we'll be building them into our first of several radar projects. We'll start with continuous wave radar, and then move on to synthetic aperture radar, and finally, hopefully close out the summer with passive radar. That last one has me the most excited, as passive radar essentially gives average people access to very long-range radar by simply using reflections from loud transmitters that happen to be in the area, like a radio station, TV broadcast, or even signals off of satellites. But we can also use it on smaller scales with things like Wi-Fi. There's some other radio projects and pieces planned, but those are the things I'm the most excited about. The next question is broadly related to batteries and those sorts of videos. Many of you have asked for follow-ups and where the battery project was. Well, honestly, I've gotten busy with other stuff, and it'll take a while till I can work on that stuff again. That's not to say I'm not going to, but that may need to wait until either next winter or much longer, as there's just so much other stuff going on. A friend of mine is currently building a kiln for the lab, and once it's finished, I'll be able to start doing some hydrothermal reactions, and probably some battery stuff again. However, that same friend and I have two other projects going that right now interest us far more than batteries. The first is a cold plasma generator, and the second is growing synthetic gemstones like rubies and sapphires. We've been slowly collecting the parts for both, and the cold plasma should actually be functional soon, hopefully. But then our attention will really turn to the gemstones. There have been a couple ruby making videos that have come out, but the rubies people make are these teeny little globby specks. We aim to make a much larger, proper boule, ideally of reasonable clarity, so that way we can have huge hunks of ruby and sapphire to play with. We're currently pricing things out and collecting parts, and aim to start the next month or so. For those who are a bit confused, ruby and sapphire are the same gem, just with different impurities. Chrome makes rubies red, and titanium makes sapphires blue. The process for making each is exactly the same, and you can actually get a huge array of colors by changing out the impurity. Both are made of aluminum oxide and can be made synthetically by just melting it and reforming it with a little bit of impurity. Once that project is done, we'll likely start to tinker with the kiln and battery stuff again, and we've even talked about giving carbon nanotube synthesis a try. But all that and the battery stuff is so far down my list, it'll really most likely be a year before we get back around to it. But I do have some ideas I want to try, so I'm not dropping it entirely. If you're looking for battery videos, go check out Robert Murray Smith's channel. He has a lot of great stuff. Moving on, many of you have been asking about the kombucha leather video and the wallet I made. Well, after more than 2 years, it finally has started to break apart. Turns out 2 years of going to bars and betting people that they can't rip a thing eventually wears it down. So I went to the store, bought myself a bottle of kombucha, and I'm now growing some fresh SCOBY to make a new wallet. That's one of the things I love about this material. It's biodegradable but fairly durable, so 2 years of solid use and abuse and I can compost it and make a new one. But this time, I want to stretch that lifetime out. Since I first made the kombucha leather video, myself and many others have been experimenting with different methods to treat the final product to change its properties, as well as different growth methods, growth media, coatings, and more. We've learned a lot that I'm really excited to apply to the new wallet and hopefully make some larger items. So once that's grown enough, expect to start seeing updates and then eventually a sequel to the original video. And finally, James Parsons Jr. asks, what are my thoughts on using bacteria to grow bricks? Well, that's actually one of the end goals of the spider silk project. The silk itself is just there to give the growing bricks structural stability without the need to have huge amounts of filler that you would otherwise need to source elsewhere. But generally, I love the idea of biological bricks. The trick, though, will be to find mineral sources to supply the starting material for the bacteria that don't require lots of energy or chemicals to produce. Because if you still need to dissolve a bunch of limestone as feedstock, the whole point of using bacteria to make your bricks is kinda useless. Something that uses a waste stream from another process would be ideal and make for super environmentally friendly bricks, which I think is awesome. And that's where I think I'll end this episode. If you're as excited about all these upcoming projects as I am, then be sure to hit that subscribe button and ring the bell to turn on notifications. And if you'd like to support the channel and help make these projects possible, then head over to my Patreon and consider kicking $1 or $2 my way. Every bit helps cover the cost of projects as well as allow me to focus on making videos full time. So thanks as always to my amazing patrons and channel members for the incredible support. That's all for now, and I'll see you next time.